Okay, so this is Circuit Theory Laws, the review from the test. The optional activity for people who got an 80% or better on that test that you should have back in your hands. That means you got at least a 32 out of 40 or a 29 out of 36. Everybody else, I'm going to say that it's mandatory so that you can improve your grade. There's only a few days left in the quarter because of Sandy, so let's get it done. You need to, on a separate piece of paper, write the answers to the problems reviewed in the video. You're going to attach that new work to your original test and submit all the work together. Any correct work on the new pieces of paper will be awarded half the points originally deducted. So if I subtracted 6 from problem number 1, and you completely redo problem number 1 correctly, you'll get 3 points back on your original grade. In order to get it regraded, though, you have to do the whole problem all over again, because sometimes the problems work with each other, and if you only redo the part that you got wrong, then it can affect some of your other answers. So you must redo the whole problem in order for the points to be awarded. Then, after you've done that, I have one new question for you to complete that'll be based on the review that we've done. It'll go in as a summative grade. So again, if you got an 80% or better, it's up to you whether you want to improve your grade or not. So let's get this going here. Alright, so here is problem number 1. I've got my voltage source that has 6 volts. I have 3 resistors. Resistor 1 is 100, resistor 2 is 150, and resistor 3 is 50, and that is, of course, all in ohms. This series circuit, and how do I know it's a series circuit? If you notice, there's only one path for the electricity to take from the positive terminal of the battery all the way around to the negative terminal. So therefore, this is a series circuit. All our rules for series must apply. So let's get a thinner pencil. The first question is that we need to find the total resistance. Total resistance in series is the sum of all the individual resistances. So I have resistor 1 plus resistor 2 plus resistor 3. Then you put in the values. So that's 100 plus 150 plus 50. And whether you use the calculator or you actually do it all in your head, you should be able to get 300 ohms as your final answer for the total resistance. There's no need to convert that. That's already properly written in SI notation. Next, I need to find the total current. Since it's a series circuit, no matter where I calculate this current, it'll be the current everywhere else in the circuit. So I'm going to take my total voltage that I started out with and divide it by the total resistance that I just calculated. So that would be the 6 volts divided by the 300 ohms, and that should get you 0.02 amps. But that's not done. Need to convert that, because this is a decimal. Using SI notation, the correct answer would be 20 milliamps. And again, we do that, right? This decimal point needs to go one group of 3. That means I have to stick in an additional 0, so I get my full group of 3, and that brings me to the group milli. Alright. Our next calculations are all voltages, and they're actually calculated all the same. Remember that the current runs through all 3 resistors. It's the same current that runs through all 3 resistors, so in order to find the voltage at just resistor number 1, the voltage at 1 is going to equal the current times that resistance. And so voltage 1 is going to equal the 0.02. Make sure that you use the value in regular amps times the 100 ohm resistor should get me a voltage of 2 volts. I'm going to repeat the same steps for V2, except I need to change my resistance to match the resistor I'm talking about. So this would be times 150 ohms. So I end up with 3 volts. And repeat the same steps for the third resistor. Times the 50 ohms, and I'm going to end up with 1 volt. Now for part F, Kirchhoff's law tells me, the voltage law tells me that if I start out with a certain voltage, the sum of all the drops has to equal what I started with, right? Conservation of energy. So I started out with 6 volts. And I want to know, so this is really a test, that's why I put the question mark there. Does 2 plus 3 plus 1 equal, all in volts, of course. And I do end up with 6 volts equaling 6 volts. So it checks. And this is my KVL. Helps to check your work so that you make sure you've gotten everything correct. Alright, problem number 2. Problem number 2 is a parallel circuit. Right? There's more than one path for electricity to flow. It could flow through resistor 4, resistor 5, or resistor 6 and still end up back at the battery. So total resistance in parallel is the one with the reciprocals. So I have the reciprocal of the total resistance is going to equal the reciprocal of the first resistance plus the reciprocal of the second resistance plus the reciprocal of the third resistance. When I substitute my values in, I get 300 to the negative 1 and 300 to the negative 1 and another 300 to the negative 1. Now because they're all the same, I could save myself a little bit of time, and I know that there are 3 of them, 300 to the negative 1. At this point, you need to be very careful with what you put into the calculator. And I think some of you made that error. So here's my calculator. And you notice on this calculator, it's the 1 over x key. On some of the graphing calculators, the TI-84s or the 83s, it's going to be x to the negative 1. Also on the calculators that are in the classroom, it's going to be x to the negative 1. So I'm going to do 300 and the 1 over. I'm going to multiply that times 3, and that's going to equal, but this 0.01 is not my final answer. That's the reciprocal, right? If I put this in correctly, I'm going to get 0.01. But I actually need the reciprocal of that. So I need to hit my 1 over one more time so that I actually get my total resistance to be 100 ohms. Alright, so for the next one, we needed to calculate the total current. So you can think about this as I've now changed this circuit. Right? I still have my same battery, but now I only have one resistor, and that one resistor is 100 ohms, and this was my 9 volts. So if I only have one, total current is going to equal my voltage over my resistance. So it's going to be the 9 volts divided by the 100 ohms, 0.09 amps, which is best written as 90 milliamps. So now I know that the current that's right here is 90 milliamps. And then that current gets split into 3 branches. But because all my resistances are equal, I know one thing, that I4 is going to be the same as I5 is going to be the same as I6. That is only because R4 equals R5 equals R6. If these were all different, then these would be all different. There's a relationship. You can actually calculate all 3 of them separately, but in the interest of time, I'm only going to do it once. So I'll pick resistor 4. I want to know the current at resistor 4 is going to equal the voltage at resistor 4 divided by the resistance of resistor 4. But since this is in parallel, the 9 volts is going to be the drop for all 3 of them. They'll all have the same voltage drop of 9 volts divided by the 300. I should get 0.03 amps, which is 30 milliamps. But I also now know, because it's the same numbers, that I5 is 30 milliamps and I6 is also going to be 30 milliamps. Now my KCL is going to tell me that my total current is going to equal the sum of all the other currents. Right? It breaks itself up into the 3 pieces. So does the 90 equal the 30 plus the 30 plus the 30? And 90 does equal 90, so it checks. So again, right, if I were thinking down here, this would be 30, this would be 30, and this would be 30. But when they come back together, this would come back to 90. Alright. Last problem. Last problem has a part of the circuit that is in series and a part of the circuit that's in parallel. It's a hybrid, and it's a little more complicated because you have to keep your rules straight. So let me be a little clearer here. So part A asks you to find the total resistance for 7 and I say comma 8, right? I want to know what's the resistance if I had just these two. Those two are in parallel, right? So since they're in, oops, be nice if I could spell. I need to follow the parallel rules. And if you don't like calling them R7, 8, I don't know, you can call them RA, right? To the negative 1 is going to equal R7 to the negative 1 plus R8 to the negative 1, which turns out to be 470 to negative 1 plus 220 to negative 1. And when you put that in the calculator, that's going to be about 150 ohms. I believe it's 149.86. So we're going to call it 150. You're not going to be able to get a resistor that's 149.86, a listed one at least. So my new picture, I still have my 100 volt battery, but now instead of these two resistors, I have this one new one that is 150 ohms. I didn't do anything with this 9 R9, so that's still there as the 1.2 k ohms, and then it comes around so part B. Part B says, now that I have this new picture, how can I combine these two to find my R total? After I did part A, now I have two resistors in series. So R total is going to equal this RA, which again, I only did that because I saw some people didn't like when I combined it as R7, R8, plus the 1 point, oops, let's do our substitutions first. Alright, so I need to do plus R9. So I'll have 150 plus, and we have to convert it from SI notation to the full 1200, and you should get, oops, 1350 ohms, which is better written as 1.35 kiloohms. So again, I've changed my circuit. Excuse my crazy arrows here. There we go. I still have my 100 volt battery, but now I just have one resistor, and that one resistor is 1.35 k ohms. So part C now asks you to find the total current. The easiest thing to do is to look only at my new circuit and talk about the total voltage of that divided by the total resistance, which I just calculated. So that should get me 100 volts divided by 1350 ohms, and that should come out to be 0.0741 amps, which I will write as 74 point, decimal points here, 0.1 milliamps. Now, depending on how you round it up here and here, you might be slightly off of that, but Shouldn't be too much. Alright, let's scroll just a little bit more room here. Alright. Part D. Part D says I just want the voltage drop right here across just this resistor. But that resistor is the same, they'll have the same voltage drop, right? R7 and R8 will have the same voltage drop because they are in parallel. So if I find the voltage drop here, they will share that voltage drop. They'll both have the same one. So the voltage drop for 7 is going to equal whatever current is coming in at that point. And I'm going to use that combined resistor so again, the current here is the same current that we just calculated there, the 0.074 amps. So if I take 0.0741 and multiply it times just the 150, I should get approximately 11.1 volts. And again, if you go back to the original 149.86 and use that instead, our numbers might be slightly off, but they are close enough. So now I know what voltage is here. Then for part E, I ask you to find the current. So what happens? This current, I total, right, is going into, right, all three pictures, it's this at the same place. When it gets to this point right here, it's going to split up into two pieces. One piece is going to go through resistor 8, the other piece is going to go through resistor 7. I'm looking for the amount of current that is only going to go through resistor 8. So that's whatever voltage is at resistor 8 divided by the resistance of resistor 8. Well, up here, I calculated the voltage for resistor 7. Right? 11.1 volts. But because they're in parallel, they have the same voltage drop. So I repeat the 11.1 volts. I go back to the 220 ohms because now I'm looking only at the current that's going through this branch. And when you put that in the calculator, you should get 0.055. That's in amps. So when I convert it, oops, this is 0, then 5. So that's close enough. Right? We'll get 50 milliamps. So let's change colors again so that you can tell where I am, and let me make myself a little area to work in. I'm getting better with the pen, I think. Anyway, part F. Part F says, let's find the voltage that comes through resistor number 9. That means I have to know the current that's going through resistor number 9. But remember, the total current comes in here, it splits into the two pieces, and then what happens? It comes back together again. So this is also total current. So if I need to find the voltage at 9, it's going to equal the current times the resistance at 9. So V9 is going to equal the 0.0741 amps times the 1,200 ohms. And when I work that out, I should get approximately 89, oops, that's a V, volts. I think it's 88.92. So now you need to complete question number 4, which will be a similar problem to this one.